morning is on oil and paint films. Really kind of the backbone of this topics course, because we're considering what makes viable and lasting paint films. One of the great things about oil painting is that it is very, very flexible. However, we need to follow a few rules to make sure that it's not going to fall apart over time. So we're going to talk about a few common phrases you're going to see or hear pop up again and again. We'll talk about some of the do's and don'ts of applying paint, and as well as what is involved in the process of paint drawing, because it's not like a watercolor. You know, a watercolor dries by the water evaporating out and then the paint film is dry. That's not the way oil paint dries. Oil paint doesn't actually dry. It undergoes a chemical change. So yeah, that's something that has to be considered when we're working on a painting for a longer period of time than one sitting. The information in today's lecture can be found in these 3 books. If anybody wants to dig a little deeper and go further into this topic, which is highly recommended. The Max Dorner book is probably the oldest of the texts. I think he's German, if I'm not mistaken. I could be wrong, but it's been revised, and there's some editor notes in there to help ease some of the translation along.
There's only one book of his?
Yes, it's called, actually let me just pull them over here so you guys can see. The Materials of the Artist. And it is Dorner, not Donor. Should be an R in here. Dorner. So this book, just to give you guys an idea, let's see. 1934. I guess it's not super old, but older than some of the texts we're looking at now. The Ralph Mayer book, which is on top here, is also an older text, but it's undergone many revisions throughout the year. So the page numbers in this one is specific for this 5th edition of the book. If you get the older editions, it won't have too much conflicting information concerning oil paint, because not a whole lot has changed, but some of the newer materials that have been introduced as far as mediums and things will be updated in there.
So do they have overlapping material, or do they present new different material?
A lot of it is overlapping, and then there will be a few little nuggets in some that aren't in the others, as well, of course, as sort of different wording and different perspectives into the same topics, which can give you a more full understanding. It's like looking at one anatomy textbook on something versus looking at 3 anatomy textbooks on the same thing. You're more likely to have a greater understanding if you read all of them.
If you pick one, which would it be?
As a simple reference guide, I would actually probably go with this last one, Engine, the Painter's Handbook, because everything is subdivided and categorized really into little topics and little blocks of information. And then there's also lots of useful charts in here as well that you can just do quick references for. So this is the section on binders on oil paint. So you can flip through to this chart, and it says the name, and then the type, the source, refractive index, viscosity, flexibility, durability, and so you can really see everything sort of laid out chart-like. So that's a good reference book. But certainly the Ralph Mayer book reads more like a book, so you can follow along through with it. And it's got a little more kind of a flow progression to it, as opposed to just, here's a bullet point on this, here's a bullet point on this. So, you know, I'd probably recommend these 2 out of the 3, but if you only had to get one, the Göttingen book would be good. And he's a painter and a restorer as well. He founded a group called Amiens, which is a materials conservation website that I don't know if the website's actually still up anymore. As of a year or 2 ago, I've noticed it hasn't been online unless they changed their web address. But for a large number of years, there were many art restorers on this website that would answer questions that everyday artists could submit, and not just anybody was allowed to answer the question. You had to be a restorer, and then Mark Otzingen personally reviewed all of the answer responses to make sure there wasn't misinformation going out there. So that's where I actually learned a lot about my materials when I first started painting, because I had a lot of downtime at my job. So if I ever had any question as far as what does this mean, what does this mean, how does this work, then you could Google it into their little forum search engine and then find a whole topic written by the restorers. So it was a really good source while it was available. It's not online as far as I know now, unless they change their web address. But this book does provide a lot of the answers. And you know, it could be one reason why the website didn't continue. Maybe they just got tired of answering the same questions over and over because people didn't want to read the book. So it's a good book to pick up. And this has actually undergone several editions as well. So you'll want to try and get the most up-to-date version of this one as you can. So yes, these are all the page numbers. It's not too heavy reading. There's maybe only like 100 pages worth, if that, of information there. And then next week we'll, I think, go into pigments or something like that. So we'll sort of expand on this. Some of the topic we talked about today will flow a little over into what we're going to talk about in the coming weeks, but we're going to try and keep it as much as we can today just on the paint, film, and longevity of the painting, just to make things concise and organized. So you can ask questions, but if the question is going to be answered in another lecture, we'll probably just glaze right over it for now.
Glaze?
We'll glaze right over it for now. All right, so a few terms that we're going to talk about here today. Bricks and mortar is a phrase you may hear some artists throw around, and that refers to the whole paint system as far as the suspension and the pigment. And it can be likened to building a wall. If you were going to build a wall, you would use bricks and mortar. Enough mortar to hold the bricks together, but too much mortar will make the wall crack because the mortar expands or contracts as it dries, and then your wall could topple. So you need the correct amount of bricks and the correct amount of mortar to make a lasting wall. And in this case, the same is true with a paint film. It needs to have an appropriate amount of pigment, which acts as a brick, it acts as a stabilizer to create the toughness of the film, with the correct proportion of oil, which will act as that binder between the pigment particles. One of the things that can happen if you don't take this into consideration is, for example, too little oil in a paint. If you look at some older artists who maybe sucked too much oil out of their paint, there could be cracking or flaking or crumbling of the paint film. Too much oil, the reverse of that, can result in paint films that wrinkle over time. And not just crack, they'll actually develop sort of wrinkles, little waves in them. Or you could get tears sort of running down your painting, streaks. And it can happen when you oil out a painting in excess too much. And we'll talk about what oiling out means later.
Yeah, does bricks and mortar including the canvas?
No, we're just talking about
Just
the paint
Okay,
at this
paint.
point. Yeah. So pigment is the brick,
Yeah.
oil is the mortar. You need the correct proportion of them to make a film, because we're really looking for a stable, viable paint film that's going to withstand the test of time.
Is that going to be determined by your environment? Let's say we live in Arizona, so we live in a harsh environment.
We live in, for oil paintings, we live in one of the least harsh environments you get. Like, our climate is almost perfect for oil painting. At least the way we keep our buildings in here. Maybe not if we're going to store our paintings outside in the sun, but yeah, for the most part, we're pretty good.
You mean constant temperature? Is that what you're
Constant temperature, not excessive humidity. Humidity can damage a painting, and fluctuation in particular in humidity can damage a painting. low temperature is more harmful than higher temperatures like 90, 100 degrees is not as damaging as, say, 30 degrees to a painting, because the cold temperature will really cause the painting film to contract. And so if it does a lot of contraction and expansion, you get a lot of cracking. So we live in an ideal sort of climate to be working in, unless, say, again, you were going to go outside and do all of your painting outside where it gets like 120 degrees, then you might run into some issues a little bit with your paintings. But we don't typically store our paintings outside. When I was in Chicago, I did have some issues with, more with the canvas than with the paint film structure, because I didn't live there long enough for the paint film to be affected. But the canvases certainly would be affected by the constant shifting in humidity and temperature, because all the buildings out there are operated by radiators, and so that affects a lot of the humidity, and then there will be pockets of heat throughout the buildings and things like that. So it's a little more damaging than something out here where we can have a perfectly controlled climate with very low relative humidity. So there will be some temperature and climate effects, and those you should be aware of. But we don't have to worry about them too much here. You should know, however, that sometimes excessive heat, if you are going to be painting outside in a very warm day, depending on the ratio of everything that goes into the paint, they can become very soupy and difficult to work with, especially if wax of any type is used as a stabilizer within the paint, which that Lucas brand brags about how they use wax in there to get that butter-like consistency, which is great and nice for working inside. But if you've ever tried plein air painting on a very hot day, that paint turns into soup puddles and becomes very difficult to work with. So temperature will have some effects on your choices. Another few things you'll hear of are long and short. So a short consistency in the paint refers to a butter-like quality to it, which is more desirable for the most part. So paint companies will modulate the ingredients within their paints to make a consistency that's more short. So short refers to buttery, good workability, good consistency throughout the paint. The answering phrase to that is long. And long refers to paint that is stringier and goopier. So, for example, traditional ultramarine blue was a very long paint. When it was put in oil, it produced these long, stringy, difficult to work with paint goops. So, ultramarine blue was not a powerhouse as far as the palette was concerned, but was typically added in small doses, or more specifically mixed in with other colors that were a little short in their own nature to minimize the long effect, because it is rather difficult. If you've ever tried, say, painting with a paint that's maybe started to dry a little, maybe you painted with old paint before and it's just kind of like goopy and stringy and hard to work on there, and you have to thin it down with a bunch of oil or medium to get it back to the right spot. That long nature is what we're talking about, that like goopy, stringy, difficult to work with.
Sorry, I missed the definition for short. Can you
Short is buttery.
Okay.
Nice buttery consistency. It's like slightly warm, creamy butter that you can just smooth in and push around and flow really easily.
It's like shortening.
Yeah, exactly. A few other terms we'll hear are fat and lean. Now this refers to the oil content within the painting, or within the paint system here. So a fat paint has a lot of oil in it. Oil is the fat. A lean paint has very little oil in it, or at least a smaller ratio of oil to pigment than a fat. And we'll talk about why this is important coming up here. Another phrase you'll hear is thick and thin. A lot of times you'll hear thick over thin. Now that refers, people will use that phrase for a few different things. Sometimes they refer to it meaning the fat over lean when they say thick over thin. So thick would be fat paint, thin would be lean paint. But other times it's referred to the actual consistency of the paint, the actual thickness of the paint. Thin being paint that has been spread very thin, thick being paint that is built up topographically or more like an impasto. And again, you would follow the same sort of layering rules as the fat over lean, that you want thicker paint for the most parts to be on top of thinner paint because of the nature of flexibility that's created in the film.
So an example of thin would be like a dry brush?
Yes,
Okay.
a dry brush that
Or scumble.
doesn't have too much, yeah, or scumble. Scumble would be a better example of thin, yeah.
Okay.
So you preferably want fat over lean.
Yeah, and we're talking, when we, well, her question was about thick over thin. So with thick over thin, the only thick we really have to be concerned about would be something like an impasto stroke we wouldn't want to scumble on top of. But you could be okay stumbling on top of body paint, and you wouldn't have too many negative effects. But putting a thin piece of paint over a thick impasto glob, like something like this, most likely the thin paint is going to flake off or crack eventually. But if it was a scumble over a body paint like this, you'd probably be okay. It would have enough to grab onto, and it wouldn't crack.
And then the lean is usually because you've added some kind of medium or some kind of,
It could be, but it could just refer to paint that has less fat in it.
Okay.
So for example, body paint here is leaner than perhaps paint where I've added some oil medium to it to make it fatter. Or it could be paint that has been thinned with thinner.
So it's relative to what's
Relative,
on top.
yeah, exactly. Yeah, thick over thin, fat over lean, these are relative ideas. So for example, you don't always have to start with paint that's been thinned with mineral spirits. But when you paint, you just have to make sure that each layer is progressively the same level of fatness or fatter than the previous layer. So we'll get more into that in a couple minutes here. But so fat typically refers to more oil content. Thick typically refers to thick impasto strokes over thinner films. Pigment. Pigment is the actual powdered color particle. We'll get really into pigments coming up, but a pigment is important in and of itself because they all have different oil absorption rates. So, for example, some colors don't take oil very well, and they resist taking oil. Some pigments take oils really, really easily. So this has to be considered when you're not just making a paint, but also applying paint layers. We'll talk about here in a bit. A drying oil versus a non-drying oil. You'll hear those pop up in the books as well. So a drying oil is something that we expect to dry in a relatively short amount of time to make a painting workable throughout the life and progression of a painting. So we're talking about linseed oil, poppy oil, or walnut oil. You know, those typical oils that you're going to see in the art supply store, those are drying oils. Versus a non-drying oil is something that takes so long to dry that it ultimately will create a spongy film that is not viable for painting. So if we consider something like olive oil, clove oil, takes so long to dry that you don't want to use it in excess. So you do have to be a little bit selective. Not all oil is the most ideal to use for painting, so we have to consider that. Question?
Have you done that? Have you tried using different oils just to see?
You mean non-drying oils? I've used a little bit of clove oil to an extent, and when I say a little bit, you know, I mean we get a big if you consider like all this paint volume, so about that much, and then maybe 1 or 2 drops of clove oil in there to extend the paint a little bit. You just have to be careful though. The more of the non-drying oils you add, the spongier the paint film will become and the less stable it will become over time. So you do need to be careful. Yes?
I'm curious about the, and I don't know if this falls under pigment or drying oil, but I have some paint that's kind of old,
Mm-hmm.
and it's titanium white, and it takes forever, like weeks and weeks and weeks to dry.
Oh, interesting.
So I was just curious,
sure
is it something about the composition of it, or aging, or
Yeah, well, do you know what brand it is, by chance?
No, I mean, it might be like Winsor Newton or something, like, or some Parker or something like that.
There's several reasons that could be the cause of that. Now, paint companies will introduce additives to the paint that they actually don't list on the tube, which can increase or decrease the speed of drying time. And then if it's an old paint, it's possible that some of the oil is separated within the paint tube and most likely migrated towards the top of the paint tube. So when you lay out the paint, the oil, paint on top has a higher oil content than the paint on the bottom, which might extend the drying time. That's the most likely cause. But the really good, best grades of oil paint should not lower in quality too much over time. So if you've opened a tube of paint that's pretty old and it's starting to get gelatinized on the inside or hard, that's called livering, and that happens with lower quality paints or even some medium grade quality paints, whereas it wouldn't happen with the high grade quality paints.
What's the difference?
What's the difference what?
Why do the cheaper ones dry out faster?
Because of the stuff that the companies add into it.
Like the binders or whatever?
Not the oil is the binder.
Oh,
Yeah, the oil is the binder. But that's a good time now we can launch into our conversation about what is oil paint and the films that it creates.
One more question about the drying. So could you run into a problem if you have paints that dry at different speeds and you layer them on top of each other?
Absolutely,
Okay.
yes. So if I don't address that as we start to talk through this, then we'll bring it up after we talk a little bit more about what goes into a paint. So the Ralph Mayer book has a really good illustration on pigments and what you can kind of envision them as, and then how they're muled or ground into the oil to create a paint. So they start out as these clusters. And the muling process is done with either 3 or 5 rollers at the paint company. Just depends on whatever they use. And the paint goes through these rollers, the pigment goes through with the oil, and it smushes the paint into the oil and starts to disperse it. So they'll send it through the rollers once, and then they'll usually send it through the rollers again until the ideal dispersion is, nice, evenly placed pigments suspended in oil. So that's ultimately what we're trying to achieve. Hand ground pigments are typically inferior in quality to the commercial grade because the commercial grade they're using powerful machinery that's very controlled and sent through several times to ensure dispersion. The other thing is that the machines are carefully calibrated so that the pressure is not so immense that it's crushing the actual particles of the pigment. It's just dispersing them enough. So pigments, different pigments, come in different sizes, different shapes. And you don't want to break them up too much beyond the ideal size or else they'll lose their potential power. So we need to keep the ideal pigment structure but have it evenly dispersed. And so the paint companies have gotten pretty good at doing it. The Mayer book does describe how you can hand grind your paints, but it's, like I said, generally agreed that the machinery can do it better, and the machinery can even be calibrated to produce some of the effects that hand ground pigments produce if it were actually desired. But our goal is to get pigment evenly dispersed so that you don't have clumps or pockets of pigment. If you get pockets of pigment, then you can have uneven drying time and cracking and flaking and powdering. So we have to be careful about that. The other note about pigments that we talked about is that they have different oil absorption rates. So these pigments require different amounts of oil to be turned into oil paint. Now, paints that have really high amount of oil index, you're going to have to really dump loads and loads and loads of oil into them, which actually makes them a little less structurally sound. So fillers are added to it. The reverse is true too. Some paints that just require a tiny amount of oil to be turned into a nice fluid paint would produce a paint that has too high of a pigment content. Remember we talked about too high of a pigment content versus oil content makes paint that could flake away or crack. So if you have a pigment that only requires a little tiny amount of oil to be workable, then you're going to have a very high pigment load in the paint and it's not structurally sound. And then the reverse is true. If you have an oil or a pigment that takes tons and tons and tons of oil to turn into a paint, you're going to have that other situation where you have too much mortar and not enough bricks to create a viable structure in the end. So there are certain additives that paint companies utilize to make their paints consistent across the board. If we were to go back in time a few hundred years ago to where artists were actually making their own paints, you would discover that each paint has a very different working property. Like I said, some are very long, some are very short, some have gritty textures, some have plastic textures, and you have to have a very extensive knowledge of each pigment to be able to manipulate it correctly to produce the paintings that we see in all the old museums. And this is one of the reasons why glazing has been popular with oil paint, because you're just taking a very small amount of pigment and sort of tinting a prepared recipe of oil of the appropriate fatness and structural content with a tiny amount of pigment to build up the paint. So it was a safe way to paint back then and easier because of the challenge of working with the pigments and their different oil absorptions. But now we have things called stabilizers. And yeah, that's something that we should write down, a stabilizer. So the stabilizer are often things like metal soaps, aluminum stearate, and that's spelled thusly, aluminum, and then it's S-T-E-A-R-A-T-E, I believe, aluminum stearate. And so this is a colorless, lightweight powder that's added into the paint to modify it in some way. As far as the pigments with low oil absorption, aluminum stearate or zinc stearate will coat the pigment particles, forcing you to utilize more oil to turn them into a paint. Thus you have a more balanced equation of oil to pigment. Beeswax can also be used, and that beeswax again will coat the particles, requiring you to add more oil to turn them into a paint. And thus we can even out that ratio of pigments to binder to get it to that ideal consistency. When we look at the modern paint manufacturers, you know, talking about like Gamma, Rembrandt, people who've been making it for long periods of time and or have been doing extensive scientific research on getting the structure of paint films really sound, we can for the most part trust that they have found a good formula for how much of what they need to throw into the recipe to create a good paint without worrying about it too much. If you get into some of the lower quality paints though, some of the off-brands or some of the student grade paints, you have to be kind of careful because there are additives called extenders. Some books will refer to them as adulterants. Dun dun dun.
Blasphemy.
Blasphemy, yes, we shall stone these paints. The extenders or adulterants are typically things like aluminum stearate that are colorless but can give volume. So instead of just being used to stabilize the paint and give us an even consistency across the board, the extenders or adulterants will be added to the paint to beef up the volume of it and make it look like you're getting a good quantity of paint for a small amount of money. This is especially true in cadmium colors, in the more expensive colors. So that's why a student-grade cadmium paint can be a third of the price as a professional-grade cadmium paint because they've loaded it with colorless filler, which is low enough in impacting the body color that you would open it up and it may look exactly the same. But what happens is it's eating up the tinting power of the paint. So when you go to mix it with other colors, your mixtures become dull very, very quickly, if not immediately. For an example, the limited palette that I recommend, the ivory black, the yellow ochre, and the alizarin crimson. Now, if you use artist-grade materials, those colors have sufficient staining and coloring power that they will produce, as I've shown you guys, a very nice, large range of colors that can adequately capture the human figure in like Northlight or studio conditions. However, I did teach a workshop recently where a student had student-grade versions of those three same colors, and those colors are already typically low chroma, so they're not as colorful as some of like the cadmiums. So when you bring in a student-grade version where a large portion of the color has been filled with aluminum or zinc stearate, then all of her color mixtures immediately would just become grays and browns. Like she couldn't get the oranges and pinks and the greens and all those other colors that we would expect to see with this limited palette because a couple of those colors mixed together and they were just gray. There was just not enough pigment to carry the weight of the mixtures.
What about hues? Is that something completely different?
Hues are different, and hues, it would be better for you to use a hue of an artist grade than a actual color, I would say, of a student grade. Because the hue of an artist grade, we'll talk about when we get to the section on pigments, but it's a colorless pigment that's been dyed to create something that looks like a pure color. But it will still have, again, typically a larger pigment ratio to filler ratio. So when we look at the addition of these extenders and stabilizers in paint and compare them to what we see on the market here, we're going to see something that's similar to this. If we were to draw three paint tubes here, and this actually is in the Meyer book, so you can get a little preview here of what to expect. So he describes three paint tubes, professional grade, and then the medium or upper medium grade, and then the student grade. So here in the professional grade, you'll see something like 50% oil, 50% pigment. Now this is going to be something like Old Holland. You open it up, you squeeze it out, and it's a stiff paint. And it's because there's a balanced ratio 50-50 for the most part of oil to pigment. And it's expected that you, the artist, will add pigment or additives to make it fluid to the degree that you require. The more common grades that we're going to see on the market here are going to be something like, let's see, 50, no, I think it's 60, 60% oil, and then 30% pigment, and then 10% of the aluminum stearate. So this will allow the colors to be stabilized and be more flowy out of the tube, and similar across the board. So for the most part, when you lay your colors out on the palette, they're going to have an even consistency and workability. They'll be really good for typically like wet into wet working, maybe even in Popsto, things like that. And the amount of aluminum stearate in there is getting kind of high, but it's not so high that it's really disrupting a lot of the color mixture. I think the books recommend for the higher quality paints, typically at most 2% aluminum stearate is added to not affect the color at all. And then beyond that, you may start to see a little bit of color degradation in the actual.
How do you classify this? You said the other one was professional. I mean, is this?
Well, this is like high-end professional.
Okay.
This is the majority of what we'll see on the market now. So probably like your Rembrandt, Gamblin type of paints. And then the last one we have, the student grade, we're going to see something like 20, or maybe even 10 here and more oil, but something like this. So more aluminum stearate. And possibly even more aluminum stearate than that. So the more filler they add in here, the less color and power we're going to get. And then there becomes a danger too. Especially if it's a student grade or equivalent type of paint by a company you haven't heard of that hasn't been around to give us a track record of their student grade materials. They may throw in so many extra adulterants, even beyond what we talked about here today, that it can produce a weaker paint film overall. Because the aluminum stearate isn't as strong of bricks as pigment. So the more junk you throw in there, the less stable over time your paint film can get.
Like Taco Bell.
Sure, like Taco Bell.
All filler note or like?
So what are the brands for high-end?
Old Holland is one. I think Vasari is probably another. I believe I've heard good things about Blocks, although I've never used it. So we're talking about paint tubes where you're getting a little guy here for like $30.
Is that like Michael Harden?
Yeah, I think his is probably a pretty high quality paint. Yeah.
So all those are typically going to be like a stiffer paint.
Yes, and that's a good point too. Stiffer. Do we have stiffer? Is a good stiff. Is a good term to be familiar with. So that's when you lay it out and it's a thicker paint. It's not really brushable right away. And actually, Winsor Newton is stiffer, I would say, than other brands right out of the tube. Although it's unlikely due to the fact that they have a more even paint mixture because of the cost involved. It doesn't seem likely that they're able to support a claim like
Well,
that.
could the fillers also make it stiff?
Yes, yeah. The fillers can be modified to make it stiff. And as well as the short or stiffness of a painting, fillers are used to modify drying times quite a bit. So the ideal is that all the paints, or most of the paints, within a company's range, they try to set them to dry at a predictable set over the course of maybe 3 to 5 days, and all the paints trying to fall into that 3 to 5 day range, with a few exceptions based off of just how powerful the pigment is as far as their drying time.
So, excuse me, the definition of stiff is just the
The-
hardness of it?
The firmness of the paint out of the tube.
You talked about low oil paints where they had to use these extenders to make it more stable. Is that the same thing true for high oil paints that you need to use?
Yeah, they can use additives to make the paint a little more accepting of oil, or resistant to oil. It can go both ways.
Okay.
Yeah. What were we? Oh, the drying times of paints. Yes. So if stabilizers were not used in the paint, then your paints would take anywhere from maybe a half a day up to a week or two to dry the various colors. And so you'd have to end up really planning out how you add your colors. So the initial process of glazing, where you would glaze a paint color on there and then wait a few months, would allow for various drying times. But in today's day and age, if you want to go back to the studio each day and work on a painting, you need to have a relative expectation of it being dry or not dry, or depending on how you want to paint the painting. So because of that, companies are throwing all of this extra stuff in. Some people will say that paint companies have no rights to throw in all this extra filler, especially since they don't have any obligation to list what they're putting in the paint on the actual paint tube. But the point is generally made that most artists do not have enough knowledge of materials to compensate for the various stiffness or shortness of the paint and the various drying times of the paint. So companies are in the clear for adding all this stuff to make it more convenient for the majority of painters. And then you would most likely, when you get to these higher quality paints, or if you're going to do all the hand grinding, you're going to have to become more aware of the individual pigments and the power they hold over these properties, which we'll talk about later in the road. So that's kind of what's in our paint. Any questions on that? Okay, so now we're going to talk about paint films a little bit.
Tim, I have a question.
Sure, go ahead.
If you're grinding your own pigment, do you get it down to about baby powder? Would that be, what is the correct size
The
of that?
pigment will come in the particle size you need. When you buy a jar of pigment, that'll come in a powder that should already be broken up and not clumped together. That's usually the expectation, unless you were to say go to Siena in Italy and dig out some of the dirt, then you would have to start concerning yourself. But then you have to actually read up on what consistency that pigment is supposed to be like before it's turned into paint, because they're each a little different as well. But yeah, you can buy from the art supply stores jars of the pigments that are already broken up into the correct size, and then you can just work them into the paint, or into the oil. So we want to talk about now about the paint film we're trying to create to make something that's lasting. It's generally agreed that your paint film will last the longest if you're working on a rigid support as opposed to a flexible support. So we're talking about board over stretched canvas, but of course then you have that disadvantage that's much more difficult to transport a 10-foot wooden cradle board than a canvas that can be rolled. But if your paint film is applied adequately, you should be able to work on stretched canvas without too much concern. So the main concepts we want to consider is thick over thin. That each layer of paint that you add must have progressively more oil. So if we were thinking of a paint with many films, we would have something like the drawing on bottom, which may or may not be used, executed with paint. It could be executed with pencil, with charcoal, with India ink, or with a very thin paint. So that's our layer one. Then we have paint that's thinned. And we don't use any of the traditional turpentine anymore. We use what are called petroleum distillates, which is like Gamsol and terpenoid, things like that. They're faster drying, they have less odor than turpentine. They're a better solution to turpentine. So we have paint that's thinned down. After that, we can do a lean medium. Now, a lean medium will be something that has maybe a little bit of oil and then some thinner in it to make it more fluid. So it has oil, but it's cut with thinner, so it's not as bad proportionally. Then we can have body paint, which, depending on your paint company, may or may not be flowable right out of the tube. Then we have fat medium. Now, a fat medium could be anything from a medium maybe with stand oil or something like that, which we'll talk about later on, that's really thick and heavy and fatty. Or it could be a glazing medium even. Or it could even be a impasto medium. So this will represent the top layer of the actual painting there. And then on top of that we put varnish. Yeah?
I have a question about the body paint. So if you squirt out some paint and it has a lot of oil in it, you know, like it gets top, should you block that up?
Most artists tend to block that up unless that happens and the oil is on one side and the paint is like dry and stiff and unworkable on the other side.
Okay.
Then sometimes it's worked back in. But if the paint is a workable consistency, you don't need to work the oil back in. And if you do end up working it back in, it may become too soupy. So one of the dangers of a painting is over oiling. Like we mentioned, oiling out too much or too much oil in the paint throughout all the layers. An excess of oil will not only cause issues with the film as far as wrinkling, but it can cause issues with yellowing as well. The painting will yellow more dramatically if you continually put a lot of oil in there to make it soupy. So these are our primary layers of painting, and we can interject, say, more lean mediums or more fat mediums as desired to make the system work. And you can omit whole steps. You could maybe omit the body paint. Maybe you could omit the thin paint. So there's ways, lots of flexibility with this, is what we're trying to say. And especially flexibility of painting style. So keeping in mind this simple formula for how we should add paint, and that we're always adding the more oily layers on top, you should produce a paint that is more stable, a painting that is more stable over time.
If you were doing direct painting, do you start basically at the body paint layer?
Direct painting has this really nice advantage that it's one layer.
Okay. Well,
There's
you
no
varnish
fat
it,
over
right?
Yeah, varnish on top. Yeah. So if it's executed wet into wet, basically everything's just mixing together on the surface of the paint. So even if you end up using all of these in a direct painting or an olive prima painting, they all merge into one layer. So you don't have fat over lean issues with it. You may have problems down the road if, say, you have a painting like we were talking about earlier, like a grisaille painting, like this open grisaille painting, which is paint spread so sparsely that there's not a viable film, and then you don't varnish it, and or it's on a flexible support. Something like this would be very likely to crack off over time or powder off over time.
Can you fix that scratch with your scumbling?
Yeah, I'd have to scumble it in, yeah. Just like scratch on a drawing. Just be very careful dabbing it. So yeah, direct painting has a very good structural advantage because you don't risk some of the potential hazards that can happen. Who knows why we want fat over lean? Have we even talked about that? Why should you have a painting with layers that has fat layers over lean layers?
Dry time?
Drying time, and why is that an issue?
Well, I don't think you want something drying under another layer of paint because it would cause shrinkage or cracks.
Yes, yeah. So, this is a good time to talk about how oil paint dries. Oil paint does not evaporate. Oil paint oxidizes. It grabs oxygen molecules from the air and it binds to them. And that is what becomes the structurally sound nature of oil paint. Is because it kind of undergoes a chemical change where the oil is now bound with oxygen molecule. It oxidizes, like a match burning. It's basically a slow burning match, and it actually releases a little bit of heat as it dries. And this is why you can't throw oil rags After you're done oil painting, paper towel racks, you can't just throw them in your trash. It can catch fire. And I've heard of people's studios burning down. I actually painted at a studio in Chicago. They looked over one day, their trash can was up in flames. And that's just the oil racks in there. If there's a right combination of temperature in the air and oxygen for the oil racks to bind to, then they can burst into flames. The drying oils that we're using in oil paint have a relatively low flash point. So as they dry, they burn. So keep that in mind. They're not just evaporating, they're oxidizing. So if you have oil on the bottom layers that is thick-bodied oil, perhaps you painted it thickly, like our big impasto stroke, you'll notice that the outer layers here are dry to the touch, they're fine. But when you open it up, it's wet underneath. So the top little film has oxidized faster than the film underneath. And as it oxidizes and reduces all this temperature, it also undergoes changes in size. And it actually changes in weight as well. It'll actually increase in weight a little bit as it binds with oxygen, according, I think, to the Dormer book. So there's a lot of physical properties that are happening with oil paint. So if you are painting in layers, your ideal goal is that each layer will be dry enough to avoid having this happen. So your layers on the bottom are relatively thin, so they're allowed a little bit of time to oxidize, and then your layers on top are progressively fattier and or thicker, so that they can be given more time to oxidize. So if you have this one of these goopy films that's dry on the outside, wet on the inside, and you touch it and you think it's dry, and then you glaze over it, well, that glaze is going to dry relatively quickly. The blob will still be wet underneath, so the blob may expand or contract or even move with the waving of the canvas, and then that is why your thin film on top can crack and flake away.
After the paints oxidize, is it just the oxidation process where they can burst into flames, or if you just have paints that are completely dried and oxidized, are they then it's okay, they're not going to blow up, or
Yeah,
you'll just that process?
Yeah, it's like once a match is burned, it's burned.
Okay.
Yeah. No, there's not a huge risk of your paintings bursting into flames as they hang on your wall. We're just really more concerned about the drying paint. I don't think oil paint would be as long-lived if the painting spontaneously bursted into flames.